Eighth grade. Today's lesson is all about the electric circuit. So to understand what a circuit is, you need to understand that it is the path that an electric current flows. So think of it as the pathway that the electrons are going to take. Now, in order for you to have an electric circuit, you need to have three different parts, okay? The first part is going to be your source of current, okay? Little plug for Duracell right here. This is a battery, right? It is some electrochemical cells combined to make one source of electricity. It has a positive and a negative end that we can use, but this alone is not going to light anything up, right? It's not going to turn anything on. It's not going to do anything. I need to add some things to it. So the first thing I'm going to add is a set of conductors. Now, conductors are wires, okay? In this case, we got a red one and a black one. It doesn't really matter what color they are. This is just to help you remember positive and negative as things go. But anyways, what you do is you attach them to your source of current, okay? So again, nothing's lit up, right? Nothing's happening, nothing's being turned on. It's just there because you need one more piece. And that one more piece is a load. Now, the load is simply a device that you are turning on. So in this case, my load is a light bulb. Now, you'll notice it's not turning on yet, okay? Because it needs to be connected. So I need to add this one here to my light. Let me see it flickered there for a second. Sorry, I'm having trouble getting it to stay on. There we go, okay? Now we have a light bulb. That's powered on and electricity is working and you've got a complete electric circuit. This is what we call a closed circuit. Now we call it a closed circuit because it is a complete path for the electrons to follow, okay? So they start at the battery, they go through the black wire to the light bulb, through the red wire and back to your battery, okay? That's what we call a closed circuit. But sometimes there can be a gap. And when there's a gap, notice what has happened, okay? I still have all my pieces, but they're not connected. So that gap is what we call an open circuit. Now this can be super helpful because of this little device right here, this light switch, okay? Now, if I take both ends of my wires, I'm gonna attach the red end to the metal over here. Notice I'm always attaching to metal, right? Because metal is a good conductor of electricity. So connected, I'm gonna connect it to my load here. Again, load is the light bulb, right? And you'll notice it is a complete path, but my light's not on, okay? Now, why is it not on? Because within this switch, it's on the off position. And because it's on the off position, there's actually a gap in my circuit. If I flip it on, then what do you notice? My light bulb, sorry, it's like, there we go. My light bulbs come on. Again, sorry, the metal on this one is not so great, okay? So a switch can, excuse me, did I unplug something? There we go. A switch can open and close the circuit, okay? Now, sometimes, and this is really handy for things like flashlights. Another example, which we would have done at school, this is an energy stick, okay? There's actually electricity powering through you, okay? This would be my load. My arms are my conductors, okay? My body is my source of current, and when I attach both hands, there you go, I'm lighting it up, right? I'm allowing that electricity to flow through me. So even your body is a type of circuit. All right, now sometimes you can have what we call a short circuit. A short circuit is where the current flows, it's gonna flow to the least area of least resistance. And when it does, if it's not set up correctly, it can miss the load. Now, if it misses the load, if it's in here but it's not getting to the light bulb, then the energy is still going somewhere. And what can happen is it can build up and create that joule heat. Now that joule heat will start fires. So short circuits are not great. This is what is the main, I believe, a main source of electrical fires. So how do we prevent that? Well, there's two devices that we know of that we can use. One is a fuse. I don't actually have a fuse here with me. I wish I did, but it's a narrow strip of metal, okay? And it's in a protective case. What ends up happening is if it short circuits to this area, it will cause the metal to burn out. If the metal burns out, can the electrons go through there? No, they can't. So it will just stop the electric current from going anywhere. So if a fuse burns out, the electricity can't complete its circuit. The other option is a circuit breaker, and a circuit breaker, you've seen these at your house. It's like a gray metal panel and it's got like switches on the inside. Sometimes they get flipped. Essentially what happens is there's an automatic switch in there and it'll open if the current coming through is too much. So if it exceeds the recommended amount, it'll flip open, which will cause it to become an open circuit, which means the electricity is not getting through, which prevents these fires, okay? One last thing, this is a shorter lesson today, yay! One last thing, we have to talk about the difference between series and parallel circuits. Now, these are just two different ways to make the electricity flow if you have more than one device. So I'm going to take my switch off of here and I'm going to add another light bulb. Now you can't, I'm not going to hold the battery too, but you can see, sorry, this one is not wanting to do its thing. Hold up one sec. I need to get a different light. That light doesn't like me. Here we go. Sorry for the slight delay here. I had everything set up and now it's not working. And now it's really not working. Come on, light switches. Come on, I checked this all before I started. Why aren't you working? Let me grab one more. I think there's something wrong with this wire, is what the issue is. Let's try this. I'm sorry, guys. There we go. It was the wire. All right. Notice I've got two light bulbs here. Now they are attached still in that complete circuit, right? This is what we call a series. It's one light bulb after the other with the wires going in one big circle, okay? That's what we call a series light or a series circuit. Parallel is going to be a little bit different. So it's going to come straight to the light. And then what's going to happen is you're going to connect with your wires. And it's going to be in a parallel. It's what we call branches. And so the current's divided between, both are going to light up, okay? You'll see they're both lit up. But notice this time it's like two sets. So this round here is a circle and this round over here connected to the battery source is a circle. Now, there are benefits to both, which you read about in your textbook. But I want to show you one more before we talk about that. Okay, this here is your Christmas lights. Okay, now you can't see the wires behind this. Are they series or are they parallel? Well, if I pull one out, what happens? They all went out. Now, because they all went out, that tells us that this is a series circuit. Because if you remove one, you open the switch in that circuit and you no longer have a complete path. If this were parallel, I could remove, look, I could remove this light bulb in the middle. And if it was series, this light bulb over here would go out, but it doesn't, it stays on, right? Because it's also getting its own path to the electricity from its wires, okay? Now, there is a website I'm gonna include in your, in RenWeb and stuff for you to check out, but essentially it gives you the opportunity to like mess around and create like electronic circuits, and you can try parallel and you can try series, and you can see you can create short circuits and add switches and all that kind of stuff. So I want to encourage you to mess around with that for a little bit and give it a try, see what it's like. See if you can figure out ways to make it better or not. Okay, so I think I just want to double check one thing for you guys real quick before I say goodbye. Yeah, in your textbook, it talks about how if you, with parallel circuits, if you, oh, that's in series. Okay, that's actually 15.4. Never mind. I thought I had to do it here and it wasn't in my notes. And I'm like, why what? Where is that? But it's 15.4. So, all right, that's it. Your homework today is 15.2, 1 through 6 in the Think, and then also get onto that website. It's called PHET, P-H-E-T. I'll put it in the links. Try it out. Give it a go. See what you can do. All right, we'll Zoom later and talk about the things you've been learning. Love you guys. Bye.